So this whole exercise now is how do we come up with optimal parameters like this? And if you translate the same with what we have seen here, how do we come up with optimal weights that will reduce my overall error? So is the connection between what we are talking about in weights here and what we are talking about in intercept and slope here, is the connection clear? Okay. So let's try to come up with optimal values of constant and slope in this fashion. So let's say this is my x and this is my y variable that we have seen here in data set. The first thing, as we did earlier, let's randomly initialize intercept and slope, let's say to a value of 1. So if you notice the values here, this is equal to C1, which is random value of intercept, and this is the random value of slope. Now, if intercept and slope are like this, and my equation is y is equal to ax plus b, what's the predicted value of y in this row? Yeah, so the predicted value is 15, makes sense. So that's what we are seeing here, which is C4, which is intercept, plus A4 into slope, or into D4. So that's how we are arriving at 15. If the predicted value is 15, error squared is 1849. Any guesses why we're looking at error squared? Avoid negative values, or in some way while calculating overall errors, we want to reduce, we don't want the negative values to cancel positive errors. That's the reason why we are taking error squared. Makes sense. So my error is nothing but actual minus prediction whole square. Is that clear? Okay. So if we have just this row, or whatever we have discussed so far till this point, what do you think might be the next step that we should be doing? Change the intercept and slope values in order to minimize the error. Is that clear for everyone? Okay. So in this case, so all that I have done is change the value of C4 slightly. That means I increased this intercept slightly by 0.01. Now, if I have done that, and so let's say if I have increased the value of intercept by 0.01 and we do the same error squared exercise, what does this 1848.14 mean? that the direction of change is okay, or when intercept is increased slightly, my error has also reduced slightly. Does that make sense? So that's what we are calculating here, which is G4 minus F4 divided by 0.01. Any guesses why we're dividing by 0.01? Or even before that, any guesses what this column means? Estimated DE by DB. That's the change in error, which is DE, when B, which is intercept, is changed by a small amount. Is that clear? So that's what we are seeing here. So between G4 and F4, the only change is that in G4, we have increased the intercept by 0.01. So if I do this calculation, which is what is the change in error, which is DE, when B is changed by 0.01, that's this number. Is that clear? So this whole exercise now is how do we come up with